Hey guys, today we are going to have a look at coin change problem. Given coin denominations and also there is infinite supply of them, then find the number of ways change can be made for a given value n. For example, if our n is 5 and given coins are 1, 2 and 3, then there are 5 ways we can make the change for 5, and following are the different changes. That's the problem statement. Now let's see how we can implement it. Okay, how we can implement a solution for this. First we are going to implement a recursive solution. So let's see what we are supposed to do for that. So in order to solve this problem, what we are going to do is we are going to subdivide the problems. For example, over here we can make 5 by using 3, right? That is 3 and 2, but we can 3 and 2 and 3 and 1 1, right? But we can also make 5 by just using 1 and 2, right? So what we do is we say in our sub problem that give me a count by using all the denominations we have available so far, and also give me count by not using one of them, okay, one of the coins. So for example, in the first recursive call, what we are going to do is we are going to say that we want to use 3. So what we do is we are going to subtract 3 from 5 and make a recursive call. So in the next term we are going to check for 2 with all these denominations, and similarly at the same time we are going to say that give us a count that we can make for 5 by just using 1 and 2, right? So that is the fundamental idea for the recursive solution. Now let's see how the solution looks like. Okay, I have already set up my functions. Don't worry about the auxiliary array for time being. What we are going to do is we are going to use it for our dynamic programming solution, right? So here we have our function. M is the sum and n is the number of elements in the coins, okay, number of coins basically. So our function will look like this. As we said, we are going to subdivide the problem, right? So first by using the current coin, okay, so it will be like this. So this is saying that we are going to use the current element, okay, and also we say that we don't want to, we just want to see that if we can make the change with lower denominations. So that is our recursive call. We need a boundary condition for this, okay, and boundary condition would be when the sum becomes 0, that means that this particular change is a valid change. So we check if sum is equal to 0. In that case we are going to return 1, and if sum is less than 0, that means that this particular change is not valid. And also if we have exhausted our coins. So yeah, that is pretty much it. Actually, this is our solution. It's as simple as that. Let's see if it is working fine. So our solution is working fine. Okay, so now let's see how we can actually convert this function into dynamic programming solution. So let's just copy it here. What we need is an auxiliary array. Okay, and what we want to do is we want to basically preserve the previously calculated values, right? So here let me have a look at my auxiliary array first. Okay, so this should be fine, I guess. Yeah, so once we have preserved it, right, we want to return it as well. Cool. And now we also want to use it, right? So in order to use it, we just do this. And that's it. That's our solution. Okay, so let's see if this works fine. And yeah, do note that we have added 1 to both the dimensions, and as you can see that we are actually accessing nth and sum indices, right? So we need one extra, okay, one extra element in both the dimensions. Okay, so let's see if it is fine. Okay, so our recursive dynamic programming solution is working fine. Now let's see how we are going to implement iterative solution for our problem. Before getting into the implementation, let's understand that how our solution is going to work. Okay, so this is our auxiliary array. And for 0 we are going to put zeros, okay, and for each coin we are going to put 1. What this means is basically if we we take a sum, okay, these are sums, and if we take any sum, okay, and subtract the value of the coin, if we get to 0, then we add 1 to it. Okay, this actually helps us keep our code clean. If we don't put 1 over here, then we have to actually take extra care in order to check if sum minus the value of the coin is equal to 0, right? And we don't want to do that. Okay, and so let's start with our algorithm. So what we do is we take the sum that is 1 and subtract the value of coin, which is 1, so we get 0. So what we do is we take this value and the value from the above. Okay, what it means is that how many ways we can build 1 by not using this particular coin. For 0 we have 0, right? With 0 coins we cannot have 1, right? So this be 1. And for 2, what we do is we subtract 1 from 2 and we get 1. So we take this value and add this to the 0, so we get 1. And similarly we are going to get 1 for all of these. We get 1 minus 2 is negative, right? So we take a value from above. Okay, so this is going to be 1. 2 minus 2 is 0, so at 0 we have 1 and we have 1 above it, so it becomes 2. And similarly 3 minus 2 is 1 and 1 we have over here, so this becomes 2. 4 minus 2 is 2 and this will be 3, and so will this be. For this we take value from above, for this we take value from above. Here 3 minus 3 is 0, so 1 plus 2 is 3. And similarly 4 minus 3 is 1, 1 plus 3 is 4. 5 minus 3 is 2 and 2 plus 3 is 5. So this is how our algorithm is going to work. Okay, so let's implement it. Let's copy our function declaration from here. Change the name of the function. Okay, so we are going to require 2 for loops for each dimension. Okay, now inside this, if j equals 0, what we want to do is we want to put equals 1. Okay, and else if as you can see that I starts at 1, so in order to take first coin we have to negate 1, right? So we have to subtract 1, so that we actually refer to the first coin. Okay, if sum minus the value of the coin is less than 0, that means we didn't find a value, right? So what we are going to do is we are going to take a value from above. This is minus 1. Okay, similarly else, that is basically it is greater than or equal to 0, right? In that case we are going to take value from the above and value basically the value that we actually get by subtracting 3 to the value of the coin, right? So if 3 and 2 are there, then 3 minus 2 is 1, so we take a value from first index. Okay, 2 and 1, that is right. So this is going to be I and j minus arr of I minus 1. Okay, so this is pretty much it, right? So this is how it's implemented, and after we are done we want to return that's it. So that is our implementation. Let's see if it works fine. And what I have done over here is basically we had -1 over here, so I replaced it with 0. So this index is actually 0, right? And apart from that, I have also changed the name of the function over here, right? So let's see if it works fine. Cool. So our solution is working fine. So yeah, that's all. I mean, that is how you basically implement 3 versions of coin changing problem. Okay. So if you want the code for this, I'll be putting a GitHub link in the description section, and you can get the code from there. And yeah, thanks for watching.